This is 14.8. It says change of variables. It's an addendum. So if you haven't read the main part or listened to the main part of 14.8 yet, please do that first. So this is just a single example. So I'm doing a couple of examples separated into addendums. So before I do the example, just a reminder, broadly speaking, how change of variable works is we start with one double integral over r of f of x, y, dA, and this turns us into a new double integral where we have the integral over s of f, and then we substitute then absolute value of the Jacobian dA. There are a lot of details left out right here. This is just broadly, like really abstractly what happens to give us some structure, and then we'll work out the details as we go. So the example I want to do is say find double integral over r of x, y, dA, where r is the region shown here. So this is the region between two hyperbolas. This one will be y equals 1 over x. I'm going to call that number 1 so we can reference it. This will be y equals 2 over x. I'll call that 2. Do this line. This is y equals 1/3 x. And this will be y equals 4x. And this will be 3 and 4. So this example is a bit like the previous one, the one in the main section, which involved rewriting 4 lines and then making an assignment and getting a rectangle for the new region. So in this one, we're going to do basically the same thing. So just to be clear, this is the region right here. This is our R. So first what we'll do is we'll rewrite these 4 lines. Let's say notice, or these 4 edges if you like. We can rewrite the edges. So 1, this y equals 1 over x. I'm going to write this as xy equals 1. 2, which is y, is 2 over x. That I'm going to rewrite as xy equals 2. 3, which is y equals 1/3 x. I'm going to write that as y over x equals 1/3. And 4th, y equals 4x. We'll rewrite that as y over x equals 4. So if you look at these are sort of in 2 pairs, and they suggest a substitution. So up here, I'm going to substitute u equals xy, and down here, v equals y over x. And then this changes the lines. You can rewrite this all together. This first line becomes u equals 1, u equals 2, v equals 1/3, and v equals 4. And so this tells us our new region. So in the UV plane, sorry, it's a bit sloppy. The new region, so u equals 1, u equals 2, those are here and here. V equals 1/3 is maybe here. Doesn't need to be perfect, and v equals 4. That is S. So take a second to see how that all works out. We rewrote the edges, we saw the commonalities, we made a substitution, then that gave us a new shape which is much nicer. And so as we know when we do this change of integrals, the R changes to S, so we've done that. We need to substitute for the integrand. So the integrand is xy. But that, if we look down, that's just u. So that's done. That's easy. And pull in that. So the last thing we need is the Jacobian. So in this case, because we have u equals and v equals, what we'll do is we'll use the version that works best for this. If you remember which one that was the Jacobian is 1 divided by the determinant of partial u partial x, partial u partial y, partial v partial x, partial v partial y. That's 1 divided by, so partial u partial x. So remember, all of this is coming from down here. I'm circling in green. These are the substitutions. And it might help to notice that this v is the same as x to the minus 1y. That might be easier for taking derivatives. So our partial u partial x is y. Our partial u partial y is x. Our partial v partial x is negative x to the minus 2y. And partial v partial y is x to the negative 1. Now, there's some stuff that has to happen here. So watch what happens when we do this. We get 1 divided by, this determinant is x to the negative 1y minus a minus x to the negative 1y, which is 1 divided by, so each of these is y over x. So I have 2y over x. So this is x over 2y. Now notice that this needs to be in terms of u and v for the new integral. So if we look back, we notice that v is y over x. So this is 1/2 times x over y, which is 1/2. So x over y is 1 over v. This is what we need. So finally, I'm going to make this fit right in here. The double integral over r of xy, sorry, it's a bit sloppy, x y dA becomes the double integral over s. The xy gets replaced by u. We have the absolute value of the Jacobian and dA. And that simplifies, or that iterates nicely because s is vertically simple. So u goes from 1 to 2, v goes from 1/3 to 4. The 1 over v is positive. The u's and v's are all positive in this new region, so I can throw away that, and I can just throw away the absolute value rather. I can write 1/2 u over v d v du, and that is actually a really easy evaluation. So again, another classic problem for a change of variables. Changing, again, a region that's not nice into a region that's nice. Make a substitution, see what happens to the shape, find the Jacobian. The only difference here was this point right here. This didn't happen in the previous example because the Jacobian was constant, but the Jacobian must be in terms of u and v. That's because, if you notice, it's going to go into here. And this integral is a uv integral. That's why that needs to happen. And then at the end, it's a uv integral, and we're done. So that's the end of that example. You can check the next video I upload in a while for the third example.